Okay, so this is on section 2.1. It's on trig functions of acute angles. I want you to remember not only are we going to take notes, but then we have the chart that you filled out today in class, and that is on page 50 of your textbook if you ever lose that chart, because you will need that. If I say what's the sine of 30 degrees, you need to be able to tell me that. So I'm not going to go through those on this page, or excuse me, on this video, because we already talked about that. Also on your chart, we talked about all the right triangle definitions for your trig functions. So I'm really not going to go through an example of these for this video because I kind of feel like you can already use those and or use Pythagorean theorem, okay, to solve for one of the side lengths of a right triangle. What I'm going to spend this video talking about is what I think is probably totally new to you, and that would be cofunctions. Okay, and I really want you to turn in your book to page 47, where they talk about cofunctions, okay? So we know that sine and cosecant are reciprocal functions. We also know that sine and the inverse sine are inverse functions. Now we have something called cofunctions. So again, please turn to page 47 in your book, because I'm just going to read kind of directly out of your book here for a minute, and you can follow along. So here is where it starts talking about cofunctions, okay? So it starts out by saying, in example 1, you may have noticed that the sine of A is equal to the cosine of B. So let's go down. Example 1, all they were doing was they were given a right triangle here, and they were finding sines, cosine, and tangent of the different angles. And if you notice, angle C is the right angle. So look in your book. It's kind of blurry on my screen, but I'm just referencing this right out of your book. Angle C is the right angle. And then we're talking about angle A and angle B. The sine of A is 7/25, and that's equal to the cosine of B. And that's important. Those sine and cosine are actually what we would call cofunctions of each other. Okay, so let's go back to where we were reading. Okay, so it says, and cosine of A is equal to sine of B. Such relationships are always true for two acute angles of a right triangle. So C was our right angle. The other two have to be acute angles because altogether it's 180 degrees, okay? So if we have a 90, then clearly those two both have to be acute, okay? Figure 3 is right here. Shows a right triangle with the acute angles A, B, and C, or A and B, and right angle C. Whenever we use A, B, and C to name angles in a right triangle, C will be the right angle. That's good for you to know. C will always be labeled the right angle. The length of the side opposite of A is lowercase a, and the length of the side opposite of angle B is lowercase b. The length of the hypotenuse is C. And then if you look, it talks about, that means that the sine of A is equal to A over C, because here's A, opposite would be A over hypotenuse is C. Now if I do the cosine of B, then I have to go to angle B, and the cosine of B is equal to adjacent, which is A, over C. So do you see how those two things equal each other? Okay? So, since A and B are technically what we would call complementary angles, I'm kind of down in the second paragraph here. Since angles A and B are complementary and the sine of A is equal to the cosine of B, the functions sine and cosine are called cofunctions. tangent and cotangent are called cofunctions, and secant and cosecant are also called cofunctions. Okay? So, here's something for you to recognize. In a right triangle, where C is the right angle, then angle A plus angle B has to equal 90 degrees. And that is true every time. If C is the right angle, then A plus B has to be 90 degrees. Which gives me that B is equal to 90 degrees minus A, okay, which, if I know that the sine of A is equal to the cosine of B, right? Here's your right triangle. Here's C. We'll put B here. A. Here's C. The side opposite of A, side opposite of B. Okay? So, we know that these two things are true. The sine of A. Here's angle A. That would be A over C is equal to the cosine of B. Here's B, adjacent over hypotenuse, A over C. These two things are equal. Okay? Therefore, we know that this is really equal to the cosine of, do you see, B is also equal to 90 minus A. Okay? And that is where, if you look on page 47, you get your cofunction identities. Okay? And that table is very important for you to know. Not so much that you need to memorize, but you need to know that sine and cosine are cofunctions. So let's write sine, cosine. Okay? Then we've got tangent, cotangent, and secant and cosecant. Those are our cofunctions. So I know that the sine of an angle is going to also equal the cosine of the complement of sine. So this, the sine of A, is equal to the cosine of 90 minus A. That's what's super important for you to get out of this video. Okay? Now, if you look down at example 2 on page 47, that's the example that I'm going to go through. Okay? Example 2, page 47. It says, write each in terms of its cofunction. All right, so we've got the cosine of 52 degrees. Okay, so cosine of 52 degrees. First thing you should be thinking is that cosine and sine are cofunctions. So this is going to equal the sine of something. Okay, now think about the fact that these two angles have to be complementary angles, meaning they have to equal 90. So if I do 90 minus 52, okay, this is really equal to the sine of 38 degrees. And you could even test this on your calculator. Put in the cosine of 52, put in the sine of 38, making sure your calculator is in degree mode, okay? And those two should be exactly the same, okay? So then what about the tangent? 71 degrees. How would I figure that out? First of all, when I think cofunction for tangent, it's cotangent. So that should be the cotangent of 90 minus 71 degrees. So this is really equal to the cotangent of 19 degrees. Okay? Parentheses on that last one aren't necessary. I just got a little parenthesis happy. Okay, so last one. Secant of 24 degrees. I want to write the secant of 24 degrees in terms of its cofunction. So the cofunction of secant is cosecant, and I know the two angles have to be complementary because remember the third angle of my triangle is already 90. Okay, so 90 minus 24 is the cosecant of 66 degrees. So these are written in terms of its cofunction, if you're ever asked to do that. So again, sine, cosine, cofunctions, tangent, cotangent, cofunctions, secant and cosecant are cofunctions. Okay? Example 3 on the next page just involves a little bit more algebra manipulation. Still using the knowledge that you know that sine and cosine are cofunctions, tangent and cotangent are cofunctions, and secant and cosecant are cofunctions. So if you look, it says find one solution for each equation. Assume all angles involved are acute. Remember, cofunctions only work when we're talking about two acute angles. So we need to find one solution. Okay, and they give me this equation. They say that the cosine of theta plus 4 degrees is supposed to equal the sine of 3 times theta plus 2 degrees. Okay? All right, so I'm supposed to use this equation, okay? And I need to figure out what theta is. Theta represents your unknown when you're talking about angles, kind of like x represents your unknown when you're talking about lengths or things like that, okay? So, what do I know about cosine and sine? Well, I know that cosine and sine are cofunctions. So in order for this to be a true statement, in order to say that cosine of something equals the sine of something else, I know that this angle and this angle have to be 90 degrees. Otherwise, this would not be true. So I know, because those are cofunctions, that this, the cosine of that angle plus the sine of that angle, has to equal 90 degrees. And now it should be a pretty quick equation for you to solve. So, combine like terms, I've got a theta and a 3 theta, so I've got 4 theta plus 6 equals 90. Go ahead and solve that. For theta, you should get 21 degrees. Okay? Then if I were to plug 21 in back up here, you could make sure that together your angle actually equals 90 degrees. Okay? So, what about the tangent of 2 theta minus 18 degrees equals the cotangent of theta plus 18 degrees? Okay? Well, I want to solve this. I'm trying to figure out what theta is. I'm really trying to figure out in the long run what these two angles are that they could equal each other. Because if I can figure that out, then I really could actually check my work using my calculator. Okay? You need to recognize that tangent and cotangent are co-functions of each other, which means together, if this is a true statement, these two angles have to equal 90 degrees. Okay. What's going to happen here? It's my 18 and my 18. Those are going to go to 0. So I'm really going to have 3 theta equals 90. So my theta should really be 30 degrees. Okay. Which means if I plugged this in, the cotangent of 48 degrees would equal 2 times my 30 would give me 60. Minus 18 would be the tangent of 42 degrees. And those two things do equal each other. You can use your calculator. Oh, sorry guys, can't see. You can use your calculator to check. Okay? So, Other than what we talked about in class today where we actually filled in that chart, this is truly what this section is talking about. See you tomorrow in class. Come with questions. Write them down if you have any. See you tomorrow.